Hello there, Mr. Sutton here, bringing you the IM3 Honors 1-1 Extra Practice number 8 solutions on functions, domain, and range. For this one, we have a puzzle. Let's go ahead and take a look at that. In this puzzle, we're trying to figure out what did they call the duck who became a test pilot. And the idea here is for these first 4 questions, you have to plug some numbers into these functions. And for the last 6 questions here, they're giving you the domain. You have to plug that in to get a corresponding range given these different functions. Whatever answers you get for whatever problems you're doing, once you find them, they're telling us to cross out the box that contains the correct answer. So for example, if I do number 1 part A and I get a 7 out of that, I don't know what it actually is, but let's say that that's what I get, then I would cross off this IL. Now once you've crossed off everything, whatever letters are left spell out the answer. So with that said, let's go ahead and see what's going on with this crash or this test pilot duck. For this first problem, we're given the function f of x equals 2x minus 5. And for part A, we're doing f of 6. So we have to replace this x here with a 6. So I can rewrite this as 2 times 6 minus 5. 2 times 6 is 12, minus 5 is 7, so I was actually correct. I was just guessing. But yeah, 7's our answer, so we cross off this IL and move on to the next problem. We're using the same function now for part B of number 1, but we're plugging 1 into this instead. So this is 2 times 1 minus 5. That's 2 minus 5, or negative 3. Looking for that down below, it looks like that's going to be I, so cross that off. Next up, we've got x squared minus 4 as our function, plugging 12 in there for part A. So this is going to be 12 squared minus 4. That's 144 minus 4, which is 140. And 140, it looks like that corresponds with MB, so cross that off. For number 2, part B, we're plugging in negative 2 to the same function we used in part A. So this is negative 2 in a parentheses squared minus 4. That parentheses is important mathematically. So this is going to be 4 minus 4, which comes out to 0. And 0 is y, so cross that off. For 3a, we've got the x squared minus 7x plus 1 function, plugging 3 into that. So that's 3 squared minus 7 times 3 plus 1. That's going to be 9 minus, this is 21. 9 minus 21 is negative 12. Negative 12 plus 1 is negative 11. So all that comes out to negative 11. And this is a little more broken down version of what I just did in my head. So negative 11, that's du, so cross that off. Now for part B, we're taking the g function and plugging 0 in for all those x's. So 0 squared minus 7 times 0 plus 1. Anything with a 0 in multiplication, these first 2 terms really, is getting zeroed out. So this all just comes out to 1. And 1 is up, so up is gone. For this last plug it in function here, we have h, this crazy rational expression going on. We're going to plug 4 into that for part A. So we have 4 plus 3 over 4 squared plus 4 minus 6. The numerator, 4 plus 3, is going to be 7. Down below here we have 16 plus 4 is 20. 20 minus 6 is 14. And I do need to reduce this. This is going to be 1/2 if I reduce by 7s. 1/2, I see that right here, that's s, so cross that off. Now we're taking that fractional function and plugging in negative 1. So negative 1 plus 3, negative 1 squared plus negative 1 minus 6. Negative 1 plus 3 is 2. We have negative 1 squared is 1, plus negative 1 is 0, and 0 minus 6 is just negative 6. 2 over negative 6 can be reduced to negative 1/3, and negative 1/3 is right here, that's it, that's gone. So for number 5 through 10, they're giving us a domain of 3 different x values. We basically have to plug those into the function and come up with 3 y values that go with them. That's the range. So starting off with negative 2, we have 3 times negative 2 plus 2. That's going to be negative 6 plus 2, which is negative 4. Next, we're plugging 0 in, so 3 times 0 plus 2. This is just 0 plus 2, which is 2. And finally, plugging 2 in, we've got 3 times 2 plus 2. That's 6 plus 2, which is 8. So we're looking for negative 4, 2, and 8. And I see that right down here, this IN, that is going away. For number 6, we have the g function, 9 minus 5x. Plugging negative 3 to start off with into that, we have 9 minus 5 times negative 3. Negative 5 times negative 3 is 15. 9 plus 15 is 24. Next up, let's plug negative 1 in. So we have 9 minus 5 times negative 1. This minus 5, negative 1 is really a plus 5 then. So 9 plus 5 gives us 14 for the second number. And then finally, plug in 1. So 9 minus 5 times 1. That's really just 9 minus 5, which is 4. So 24, 14, and 4. Here's 24, 14, and negative 7. So close, but not quite. Over here we have those three numbers, so that's BE going away. For 7, we've got a little bit more going on with this function, some quadratic fun there. So let's plug in 5 to start with. We have 2 times 5 squared minus 1. Now using PEMDAS, we have to do the exponent first. So that's going to be 25 times 2 is 50. 50 minus 1 is 49. Next up, let's plug 1 into all that. So 1 squared is 1 times 2 is 2. Minus 1 is 1. And then finally plugging negative 4 in there. Negative 4 squared is 16. Times 2 gives me 32. 32 minus 1 is 31. So 49, 1, and 31. There's a 49, but nothing else is the same. Here's what I want, 49, 1, and 31. So bye-bye SK. For numero ocho, we have the h function, x squared minus 8x plus 3, and we have 1, 0, negative 1 going in there. Let's plug in 1 first. So 1 squared minus 8 times 1 plus 3. That's going to be 1 minus 8 plus 3. 1 minus 8 is negative 7. Negative 7 plus 3 is negative 4. Next up, let's plug 0 into all that. We've got 0 minus 0 plus 3, so that's just 3. And finally, plugging negative 1 in there. Negative 1 squared is 1. Negative 8 times negative 1 is a plus 8, and we still have that plus 3 there. 1 plus 8 plus 3 is a total of 12. So negative 4, 3, and 12. Let me see if I can find that. Negative 4, 3, and 12 right here. H. Goodbye. For number 9, we have a fractional function going on, plugging 4, 0, and negative 4 in there. So let's plug 4 in first. We have 4 squared plus 4 times 4 over 4 minus 6. 4 squared is 16 plus 4 times 4, that's another 16. So that's 32 up there. Down here we have negative 2. And we do need to reduce it, so 32 over negative 2 is negative 16. Next up, plugging 0 in. We have 0 squared plus 4 times 0. That's all 0 up there. Negative 6 down here. 0 over something that's not 0 is just 0. And finally, plugging negative 4 into all that. Negative 4 squared is 16. 4 times negative 4 is negative 16. 16 minus 16 is 0. And then negative 4 minus 6 is, well, it's not 0, so it doesn't really matter. It's negative 10, but 0 divided by that gives me 0 again. So I'm looking for negative 16, 0, and 0. They're not going to repeat the 0, though. They're only going to write it once. So negative 16 and 0 is our range. So E gets going. All right, get your mental math caps on for this one. We have a capital G function, negative n squared plus 2n plus 3, plugging in negative 2 to start with. So we have negative and then parentheses negative 2 squared plus 2 times negative 2 plus 3. Let's follow our PEMDAS. Exponents first. Negative 2 squared is 4. So this is a negative 4 then. Over here, this is another negative 4. Negative 4 minus 4 is negative 8. Negative 8 plus 3 is negative 5. Next up, let's plug in 1. This should be a little easier. So this is 1 squared with a negative, so negative 1. Negative 1 plus 2 is positive 1. 1 plus 3 is 4. And then finally we have big G of 4. This is going to be negative 16 out here, plus 8 is going to give us negative 8, plus a 3 gives us negative 5. So we're looking for negative 5, 4, and we don't have to write the other negative 5 again. So let's just do ST there. All right, so we've crossed off everything we could. Now we're going to solve the riddle. What did they call the duck who became a test pilot? So we have AFLY, I think just A is the first letter, the first word, and then FLY, fly, ER, I think that's all got to be one word, a flyer, and then QUACK, and then ER after, so that's got to be the end of a word. So quacker, a flyer quacker. So kind of like a firecracker maybe, because he probably wouldn't be able to operate the plane very long before something cataclysmic happened. Okay, I see that. So I got to fly here. Mr. Sutton signing off.